in the meeting room. Thank you. We make up in quality, of course. All right, so I think we're ready to go, Joe, and you've obviously switched on recording.
Yes. Okay, I'm handing over.
Thank you. I'll just go. Okay, we're ready to go. So can you see me there from the camera
Yes.
Here? Excellent.
Yes, we can see
Thank you
you.
very much. Welcome, everyone, both in the room and, of course, online as well. Have we any apologies, Roy, to record for today's meeting?
Yes, we do, Mr. Chairman. Apologies for, oh, sorry.
Oh, I'll get you a microphone. Sorry. Well, maybe be switched on if it's not.
Okay, can everyone hear me? Apologies have been received from, as soon as I sit down, Rex Stevenson, David Moriarty, Chris Moriarty, and Chris Stockdale.
And Des, I think, has given an apology. Yes, for some. Des has given an apology, I think, for a number of meetings. Des Chang, yeah.
Oh, yes.
Okay, thank you very much. We might move on to the minutes of the previous OGM, which have been circulated in the newsletter. Thank you, John. Are there any questions or comments on those minutes? No, in that case, could I have someone moving the adoption of those minutes?
This is Roy. I move that the minutes of the ordinary general meeting of the 10th of May be accepted.
Thank you, Roy. Could I have a seconder?
Joe Cali, second.
Thank you. Oh, don't worry, we have two seconders. Thank you very much. Those, could I see those in favour of adopting? And I should say, for those on Zoom, we value your votes, obviously for 4 members. And if you'd like to vote, to make sure that we see your vote, the best way is to make sure your video is on so we can see the hand, or that you raise an electronic hand in Zoom, which you'll find as one of the functions. There we are. Joe has demonstrated it already for us. So can I see those in favour of adopting the minutes of the previous OGM, please? Thank you. Are there any against? Anyone having objection to them? No, in that case, I think we can safely record them as adopted. We might move on to the President's report, which was in the newsletter, so you'll have seen the President's report, I should say. I think we had an excellent presentation last month from Dr. Charlie Lineweaver, and an extremely animated and presentation, and one that if you haven't had a chance to see it on the video, you should. It's worth having a look at. In that case, I think there's nothing else. Do I need formally, Roy, to move the President? I don't think any other reports need formal adoption. So we'll move on to the General Secretary's report. And Roy, you still have the microphone, I think.
Several items of correspondence during the past month, which I think need highlighting. We received a very nice email from Charlie Lineweaver thanking us for having him at our meeting last month and speaking. He also commented that the hotel where we placed him in Toowong, the Jefferson Hotel, was very good. And from his point of view, and we should bear that in mind for any future speakers. Can I just interrupt for a moment? Okay, we had an inquiry from a school in Toowoomba asking if they could do a school night. It's a little further than we normally go, but I've passed that request on to David and he'll look after that. One of the things at an activity that David and Michael Cowley went to involved some Indigenous astronomy, and we are looking at the possibility of having a speaker on Indigenous astronomy, perhaps next year. Members would probably remember that I sent a notice to everyone on Professor Tamara Davis's election to the Australian Academy of Science, and that we're very fortunate to know Tamara and that she contributes intermittently to our meetings. So congratulations to her. There was an interesting email from a Peter Stratton at the end of May about the fireball over southeast Queensland on the 21st of April. He was asking if anyone knew the route of the fireball, you know, the direction it took. Peter Anderson had written an article in the previous month's newsletter, and he was able to pass that on, and other members were able to contribute to an interesting discussion about that with him. And there's one other item of correspondence. We have the bookings for our ordinary general meetings made for us by Tara Massingham, who's an administration officer in the School of Maths and Physics. The meeting scheduled for the 2nd of August can't go ahead on that date here because there is a university open day on the Sunday the 3rd, and all room bookings are cancelled for the entire weekend. So council today determined that instead of the 2nd of August, the ordinary general meeting in August will be on Saturday the 9th of August. I'll send a notice or more than one notice about that around so that, well, that's after we've confirmed that Tara can in fact make a booking for us. We'll try to get a booking for the 9th of August for that meeting. So that's all, Mr. Chairman.
Thank you very much. Thank you, Roy. Any questions to Roy or comments on his report? Online? No? Okay, thank you. We might move on then to the Membership Secretary's report. Julian's poised and ready to update us.
Indeed I am, Nick. Well, I'm happy to report that the membership of the AAQ continues to grow apace, with a further 3 members in the last month. So we welcome Mutahir Absar, Herman Schrout, and Anthony Tupper. And this brings our total financial membership to 132, which I think is equal to our highest, certainly in recent memory. So I submit that my report be accepted.
Thanks very much, Julian. So, have you got any questions to Julian on the Membership Secretary's report? No, thank you. I'm advised we don't need to formally approve that, as we've done that in council already. So we might move on to the Technical Secretary's report. Peter has unfortunately been a bit unwell. Are you able to do one today, Peter?
Yes, I am. Yes. So I'll just share my screen and let me know if this doesn't work. Hopefully.
Of course not.
Yes, we've got it.
Yeah. So I'm just trying to. There we go. Sorry, yes, look, yes, I'm keeping this short because I've currently got COVID and just don't want to start coughing too much. So Technical Secretary report for June, just starting with the solar system. So evening planets for the month. Mercury appears low in the northwest in the middle of the month in Gemini, moving through to Cancer by the end of the month. And on the 27th of June, a thin crescent moon is just below and to the north of Mercury. On the 17th and 18th of June, Mars passes within 1 degree of Regulus, the brightest star in Leo. And on the 29th, the crescent moon is below and to the west of Mars. And then Jupiter is low in the northwest in Taurus at the start of the month, but will disappear below the horizon after a few days. For those who get up bright and early, Venus is in the northeast in Pisces, and on the 22nd of June, the crescent moon is to the north of Venus, and Saturn is in the north in Pisces on the 9th, and on the 19th of June, the last quarter moon is to the west of Saturn. As to the moon, we had first quarter last week. Next Wednesday, 11th of June is full moon, 19th of June is third quarter, and the 25th of June is new moon. The iSpace resilience mission, well, that was launched in the middle of January, and the Japanese company iSpace have been unable to contact it since it was due to land on the 5th, which is, I think, last Thursday, and they haven't been able to contact it. So Resilience had a planned landing at Mare Frigoris, which is a basaltic plain about 900 kilometers from the lunar North Pole. They had a small rover on board, about the size of a large microwave, to go around the surface, but preliminary analysis indicates that the laser system for measuring the altitude didn't work as planned, and so the lander descended too fast, and obviously, hit the surface too fast and disintegrated. So, sorry end for that mission. Looks quite an impressive mission that's been launched on the 28th of May was China's Tianwen 2 spacecraft. It's quite ambitious. It's an asteroid sample return mission, and it's going to explore the near-Earth asteroid. I'll probably say this wrong, but Aurora. And it'll arrive there, I think it's 2027 it's due to arrive there. The idea is to take a sample and then it'll return to Earth orbit where it'll drop the sample off, and then it'll head back out to Comet 311P. So that's quite an ambitious mission there for the Chinese. And I'll just finish off by just going back to what I talked about last time, is the confirmation of dimethyl sulfide and dimethyl disulfide in the atmosphere of exoplanet K2-18b. On Earth, dimethyl sulfide is produced by marine plankton, and there have been some claims that this is a robust biosignature for life on K2-18b. In fact, there's some reports are saying it's like at 99.7% certainty that it must be of biological origin. However, reading the latest edition of Chemistry World, which is the journal of the Royal Society of Chemistry, there's an interesting article in there discussing how dimethyl sulfide can be formed by the photochemical reaction of hydrogen sulfide and methane. Hydrogen sulfide is that gas which is the smell of rotten eggs. And because we just don't know the geological conditions on this exoplanet, it's unclear how the dimethyl sulfide formed at this stage. Clearly, whilst it be great to think, yes, this is a good indicator of life on another planet, and it's still a very exciting find, we really just don't know the origins. And so I think we just need to be aware that there are other potential reasons we can have that substance present. Okay, that's it for me. Thank you very much. Any questions?
And any questions to Peter? Online? No, I don't see anyone. Thank you, Peter, and I hope you feel better soon from the COVID. And so at that point, oh, sorry, Peter, go on.
Sorry, did you hear me?
I just heard you coughing. Or the eccentricities of Zoom. Okay, well, thank you. For no questions, Peter, we'll go straight on, I think, to the main item, which I'm very pleased to introduce you. No, I don't need me to introduce, because he needs no introduction.
Oh, thank you.
Renato Langersek. I'm sorry, I hope I pronounced that.
That's fantastic. Thank you very much.
And Renato is going to talk about hunting asteroidal shadows, I think, across the US. Is that right?
That's correct. Yes.
And we might just bring up. Do you want to do it, or do you want me to do it?
Just bring up the presentation.
We've got it there, so we'll share it, shall we? And then, first of all, and then bring you up. There we are. It's done. And then we'll go back, I think, onto here. And share it, I hope. So that should be, we can all see it here. Can you see it online?
Joe, can you see it online? Shared?
No, not yet.
Oh, okay.
No, not shared yet.
Okay, we're going to go back and make sure it's been properly shared. I think that was there, wasn't it? So let's try it again. That's what I did. I don't know.
Yep.
Where is all this AI when you want it to anticipate what you're going to do next? I don't know. Let's get this online and bring it up for you.
It's here.
Oh, yes, okay. I'll just do you there. Sorry. It's fine. All right. I think we should now. Can you now see it online?
Yes.
Good.
Do we have the people? Can you turn the other cameras off, please? Otherwise.
I think, You probably know that one. Oh, there, down there.
You just
Whoops.
Renato, the image of you on your screen doesn't show up in Zoom.
okay. That's all right.
It's there we are.
No, not this one. Huh?
Yeah.
Oh, this one here.
What he's saying, I think, is that yeah. Can you now see Renato? Renato?
You should just see my presentation at the moment, isn't it?
Yes, correct. The image of you as the speaker only shows up on your monitor, but not on
Yeah.
the outgoing Zoom.
Well, we got rid of some of those to give more presentation space for the,
Yes.
for the actual presentation. So I think you'll just see Renato's presentation rather
Yes.
than Renato. So I think you may need to imagine Renato.
Yes. Please imagine me. Not much loss. Huh? Well, thank you very much for coming, and welcome to my talk about adventure hunting asteroidal shadows. Yeah? So why does the screen doesn't move? Like the screen doesn't progress.
Are you pushing it on your computer with notes or the presentation computer?
No, we're not going to
Sorry
do-
for the technical difficulties.
That's it. If you just use this
Here's the mouse.
and click it. Yeah.
So what is an asteroidal occultation? Sorry, need to go to the front. Okay, this is from the beginning. Thanks again for the for coming. Okay, what is an asteroidal occultation? An occultation happens when an asteroid moves between a distant star and an observing station. It will cast a shadow onto the station, like at the solar eclipse when you have the sun shadow fall on Earth. You actually have a very distant sun shining light on this asteroid, and the asteroid is casting the shadow. The track the shadow takes at this station is called a chord. A year ago, Melusia occulted a 12.4 magnitude star for 9.5 seconds. And here on this little screen, you can actually see the asteroid disappearing. And then it reappears, and you'll see it, the green crosshairs appear, and a little bit later, the star comes back. On the bottom right of the animation is the extracted light curve. So this is the light curve of the star that was occulted, and you can see a prominent dip in that image. So if you have multiple stations, you can have several chords. The shadow profile of the asteroid can be constructed. Because the star is so much further away than the asteroid, the shadow that will be casted on Earth is pretty much the same size as the asteroid itself. 4 years ago, NASA launched the Lucy spacecraft to study Trojan satellites. During the Why is this happening? During the 12-year mission, Lucy will visit 3 main belt and 8 Trojan asteroids. In April, it performed a flyby of asteroid Donald Johansen, and you can see a little animation here of the little asteroid, but it's not the Trojan, it's a main belt asteroid. In 8 years' time, Lucy will visit Patroclus and Monotheus at the Lagrange point 5. The Lagrange points are locations in space where the gravitational forces of two celestial bodies balance each other out and cause an equilibrium. Here we are talking about Jupiter and the Sun. With NASA's funding, the Southwest Research Institute orchestrated several reconnaissance missions to learn more about those two asteroids. In 2022, I contributed by participating in the expedition to Western Australia, and a year later to Central Queensland. Early last year, Mark Bowie, the mission director of Lucy Recon, invited me to participate in a much larger expedition on mainland US. One of the event on the event day, Patroclus and Monotheus would be about 4.5 astronomical units from Earth. The pair is orbiting the Sun with a period of approximately 12 years. And each other, the orbit around each other in about 4.5 days. And they have an average distance of 680 kilometers. Well, after traveling for 18 hours, Mark picked me up from the Denver airport. We drove past Lucifer, the red-eyed, almost 10-meter high sculpture weighing 4 tons that killed its maker, Luis Jimenez. Mark took me straight to the Lucy Recon headquarters in Meade. I must say, I had a great time in Colorado. The hospitality was incredible. Mark took me into the Rocky Mountains a week before the expedition, and all these peaks, they're about 4,000 meters high, and the scenery reminded me very much on Austria. Well, Mark has his own observatory in his backyard. Here's an image of Mark and myself in front of his Celestron telescope. The telescope has a special camera on it. The camera has a GPS input, and it's mounted on a hyperstar lens that produces a f2 imaging train. But Mark also has a remote control telescope in the other part of the yard. And unfortunately, this one didn't want to play along, and it didn't let us in. And Mark was too busy to actually fix it before we got to the expedition. And last but not least, Mark's hidden talent as a great chef. He produced a fantastic barbecue. There's no trip to the US without a barbecue. Now, that's not all. Mark invited me to visit him in his office in Boulder, Colorado. The scenery was absolutely breathtaking. On the left-hand top, you see the flat irons, which are striking slanted reddish-brown sandstone formations, and they're the border to the Rocky Mountains. So here is the building, the new office block of the Colorado headquarters of Swarry. And the balcony in the middle top is where I took the photograph of the mountains. So it was really incredible. I was invited to listen to a presentation that was given highlighting some discoveries that were recently done. And everybody made me feel very welcome. Afterwards, we even went for lunch. And I had the pleasure of eating a moose burger. So, the expedition. I was doing the stock take of the equipment for the Lucy expedition before departure. There were 30 deployment packs containing laptop computers, C11 telescopes equipped with hyperstar lenses to achieve the f2, and the HQY 1724 GPS cameras to take the images. 2 groups of 15 team members each deployed for Patroclus and Menoetius, with 2 observers per team, so all up 60 people. Brian Keeney directed the Patroclus group to New Mexico, and Mark Bowie took the route to Texas. Sorry. I'm playing here on 2 computers and I missed the transition on the other one. So on the left you have Brian Keeney and on the right you have Mark Bowie. Very intelligent people and great teachers. So Mark drove me down to Amarillo, Texas to pair up with the local observers. It was a long, long drive and it was hot, 46 degrees Celsius. And as soon as you step out of the car, you think you're evaporating, not melting. So we crossed through Oklahoma. Please note there's a big difference between the road in Colorado and the one in Oklahoma. There must be different financial reasons for this. So then we crossed over to Texas. Here's the image of the Texas border stone, including bullet holes on the front and back, because Texans like to shoot. And of course, we saw lots and lots of feeding donkeys, they call them. And they were just like a seesaw going all day. So finally, after crossing Route 66, we ended up in Amarillo, and it was really still hot. There was a quirky public art installation in Amarillo. It called the Cadillac Ranch. And it's a row of 10 Cadillacs, all the models of 1994 to 1963 are buried nose first in the ground. And the sculpture was created by in 1974 by 3 artisans who were in a group called Ant Farm. And what the purpose is, when you get to this Cadillac ranch, you get yourself some spray cans and you colorize the Cadillacs with your own artwork. So after driving the whole day, Team Margarita, named after the drink, had dinner at the Mexican restaurant La Fiesta Grande. The serves were much too big. I only could eat about 1/3 of what I bought. And the Texas flag is everywhere. You can see it in the back there. Texans are very proud of themselves. The blonde lady next to me was my team member, Patrice. And we were Team Menoetius 11, also called Station Lucy 57. That has to do with the computers that we're using to record the data. Now, we had to do more traveling. The weather was very unstable. And every day, Mark created a new list when we need to go to, and it changed all the time. You couldn't predict 3 days ahead. Our first training session started at 3 a.m. on day 2 of the expedition, and we had to find a field of interest, take an image of it, and find a target star. That was our mission. After this, we wanted to get some hot beverages because it was, although it was Texas, it was cold in the morning. So we wanted to get something hot in us. And guess where we went? And things you can see only in Texas. In other countries, kids would turn vegetarian if they saw this sort of display. So later, we headed back to Patrice's hometown, Lubbock. And Patrice and her husband invited me to stay in their house for the night. Patrice and I did a dry run in her garage. She never played with this type of telescope, so I'll explain to her everything in detail. Yeah. And then early in the morning, we got up at 2:30 in the morning local time. We headed out into our training field, and the object was to record a short video of the field of interest. So then later after that, the weather changed and we had to drive across border to Roswell, New Mexico, where we found some strange locals. But most of the aliens we encountered were from Mexico. Our training session the next morning was at the Bottomless Lake, close to Roswell. And our mission was to record a 4-minute video of the field of interest at the time of the occultation that would happen the next day. And after the weather changed again, we had to cross the border back to Texas, and that was for the whole monitors group. And we distributed to our designated areas, and we had to go onto our course. So team M11 was destined for Midland, Texas, which is an industrial town in the middle of the oil fields. You can see the flame in the background. They're every few kilometers, and the air quality is very poor. So here's a map showing the team deployment for the occultations. And there were 2 occultations because we had 2 asteroids. So the green one on the left is for Patroclus, and the gray one on the right is Menoetius. The red dots symbolize the stations that reported the positive occultation, and the blue ones were the misses. Okay, we set up. We found a car park at Greenwood Little Leagues softball club, which was exactly on the chord. And about 20 minutes before we started recording, a car pulled into the car park. We got a bit nervous. Patrice walked over there and asked them if we can help them, and invited them to have a look what we're doing. But they were busy. They were just looking for a Pokemon and left very quickly. So at the time, at 10:32 UTC, we started recording a 6-minute video at 1200 millisecond exposures at gain 300. Gain 300 is referring to the amplifier setting of the camera. And Patrice was looking very intent, waiting for the star to vanish. And although we had really gusty winds and the telescope was shaking a bit, we still had a good result. So here you can see, because of the wind, I had to filter down the data a bit for this presentation. And you can see the light curve has a 4-frame binning method applied. So which means I'm taking an average of 4 measurements, and that's recorded into the light curve. So after we finished this, we had to fill out in our observing log. And Patrice dropped me back to the hotel at 6 a.m. where Mark was waiting to take me back to Colorado. He was keen on getting back. So we took off straight away. And it was a really long drive back through New Mexico. We were crossing side rivers of Rio Grande, and you can tell that there was some rainfall fall before, because otherwise it wouldn't be so brown. We drove past little mesas. You could see some on the horizon, but going at about 80 miles an hour, you can't really take photographs with the long focal length lens. So this is all I could do, take the close ones. And then we drove into the mountains of New Mexico and coming out at Colorado Springs and going through Denver, ending up back at Lucy Recon headquarters where Brian downloaded all the records that were recorded. All the recorded data needed to go on the mainframe. And guess who was really exhausted? You can see this on the photograph, I think. I haven't been so tired for a long time. So Mark provided me with these slides to show you, and they represent shadow profiles. This occultation was particularly interesting because Patroclus and Menoetius were able to be recorded from the equatorial plane. So the red dots represent the disappearance and reappearance of the star. And you can see a green ellipsoid around the center of mass, representing the virtual asteroid. But the red dots can be used to plot the shape of the real shape of the asteroid. And as you can see, Patroclus definitely looks like a potato. Now, the shadow profile of Menoetius brings out some intricate feature. Lucy 78 recorded the occultation with the split-second brightening of the star before the occultation finished. This indicates that there should be a 700-meter gap on the asteroid where the starlight was beaming through and then went behind the mountain again. Now, 700-meter feature at a distance of 675 million kilometers, measuring that is quite spiffy. Yes, occultations are very accurate. Now, when you align the plots over the top of each other, and you compare the shadow profiles, you can see the Menoetius is definitely smaller than Patroclus. But the topographic features do not correlate. So that there are different shapes. This slide shows the area rotations of Patroclus Menoetius system measured during 4 occultations. The lat long shows the location on Earth where the occultation was recorded. The delta M is the brightness difference between the 2 objects. It also shows the approximate size and densities of the objects. And the uncertainty is about 1%, which is relatively precise due to good orbital tracking. And there's only about 3% difference in shape between the 2 asteroids. So why do we do this? Well, occultations are very precise. We better get an understanding of the asteroidal size. We can reevaluate the asteroid shapes and we can get a better orbit for Lucy spacecraft. So regarding further work, occultations are very precise, and by doing more measurements, the volume estimate of each object can be refined. To get better density measurements, we need high quality, well-timed data from several sources, especially now before Lucy flyby. When the Lucy spacecraft flies by the Patroclus Menoetius system, it will only get a clearer direct view of the northern hemisphere of the 2 bodies. So unfortunately, we can't be on both sides at the same time. That would be great, or circling around them. But unfortunately, Finances are scarce, and NASA has huge budget fundings at the moment. And because SWARI is paid by NASA to do these things, things are on the decline. So I'd like to give thanks to Mark Bowie, Brian Keeney, and the whole SWARI team for making this expedition possible for me. And I also like to thank my M11 team partner, Patrice Fay. You can see here, Mark provided some interesting links for anyone who might be interested. He's working on a blog to how to make occultation timings more accurate and make them count better. There's also a SWARI press release about the first recon mission and the results. And Mark suggests for all of us to have a look at star chasers of Senegal. There's a link here for a video. It's on Vimeo. Also, there's a link to Fiske Planetarium, which is part of the university at Boulder. And especially, there's a link to a Polymele occultation expedition video. And depending what our president says, if we have enough time, we could maybe watch this. I've got it here. But yeah, it's a fantastic thing. But the expedition was 3 times the size of the one that I was on. So after I was finished with the expedition, there's more. I went back to Houston, Texas, and I visited the Johnson Space Center. And here's a few images of what you can see there. It's just amazing walking through all this history. And you can see all these rocket motors and spacecraft. This one, for example, the space shuttle, this one actually never went into space. But yeah, it was a mock-up. But it's still nice to walk through. Just brings the size to perspective. So here is the Apollo Saturn V rocket in sections. You can actually see in between how they're coupled together. And on the left, you can see some figurines of the Apollo 13 mission. So this slide shows a mock-up of the ISS, where all the future astronauts that will go to the ISS can practice doing their job. And as you guys know, I'm a radio communications engineer and I build communication centers. So I did a site inspection of the Apollo 11 mission control. Well, thank you very much for your attendance. Any questions? Yes. Hang on, wait a bit. So we have a question by little.
Asteroid name?
My name.
What's the asteroid name?
The asteroids' name are Patroclus and Menoetius. These names are taken from the Greek history. Any other questions?
Got to ask, did they pay for your flights to the US, or was that self-funded?
No, my flight to the US was self-funded, but while I was on the mission for the 1 week, they looked after me. Any other questions?
I just a question about the asteroids themselves. You mentioned that they were orbiting around a common point themselves?
Yes, yeah. They're
Were they also-
gravitationally linked.
Okay, and were they sort of tidally locked, or were they actually spinning themselves
At the
individually?
moment, it looks like they're tidally locked, but this is, we have 4 occultations to go by. So we try to get more occultations and see how they behave. If we get more occultations that have both asteroids in it, we can get a better picture about that.
Okay, and just one last question: is that shadow that you're able to map and create with the timing of the occultation? That's a profile. You would need many occultations, would you not, to actually build the equivalent of a 3D sort of picture of its entire shape? Or
Well, what happens is we start off with one station on the ground, and each station is recording a video clip of how the star disappears and reappears. We get very accurate timing down to 1 millisecond with these cameras that we're using. That's all GPS controlled, and it's down to 1 millisecond. And then when these asteroids moving across, we are actually the fast bit. The asteroid is slow, because asteroid is out at the Jupiter orbit. But the thing is that when we're moving and the shadow goes across the ground, and you have multiple stations intercepting it and measuring exactly what time the star disappears and then reappears, that's where you can actually make the shadow profile. And the more shadow profiles you get of each asteroid, the more you can actually calculate how the shape looks like. And I believe that they will have a 3D model of these 2 asteroids already.
Can I ask one from Zoom?
Yes.
Sorry, yes, no?
Yes, Joe?
So a couple of questions. One, with that 700-meter depression that Station 78 measured, did you work out what the angular resolution was in arc seconds for doing something like that?
No, I didn't calculate this, but it actually came from the angular resolution, how they actually calculated how wide this gap is. Because when the shadow moved across, the timing would have given them the distance and how long it will actually be there.
Yeah, and the other question is, if observers are distributed longitudinally along the path, and the Earth is moving relatively fast, then there has to be a parallax effect for the timings. I presume that's taken into account when they reduce the measurements.
Well, the thing is, when you look at this scale, the shadow moves across Earth very quickly. So the occultation lasted about 16 seconds. So this is very quick in comparison to how long it takes Earth to actually go around the sun. So there won't be much parallax.
Right.
And when you look at this, not all of the stations were really on a line 90 degrees to the chords. You can calculate by the GPS coordinates where the stations were, exactly how much delay you have to impose to align them.
Thank you.
No worries. Anyone else? So do we still have time to watch a video clip or? Okay.
So where's the video then?
Go on to the This one. Oh, the shadow, yes. Okay. Will it work?
Oh.
Here it is. Here we go back to the beginning.
Yeah.
We have no sound coming through Zoom.
Lucy is going to study Trojan asteroids, which lead or follow Jupiter in its orbit by 60 degrees. These objects are the leftovers, or you can think of them as fossils, of planet formation. And did we name the Lucy mission after the Lucy fossil to make that connection? Because both the fossil and the mission are going to tell us about our origins. Lucy is going by more asteroids than any other spacecraft in history. In 2027 and 2028, we're going by Everybody's and its satellite Keta, Ptolemy and its unnamed satellite, Lufcus and Orus. And then in 2033, we're going by this cool binary called Patroclus and Menenius.
Many people have heard of or seen a solar or lunar eclipse, when the moon and Earth align with the sun, and one casts a shadow on the other. Another form of planetary alignment occurs when an object in our solar system passes in front of a distant star. This is called an occultation. Occult means to hide, and during an occultation, the star will be hidden from our view when a planet, moon, or asteroid passes in front of it. This produces a faint shadow over the surface of the Earth that we can measure to learn more about the size, shape, and position of the object. This is similar to measuring the shadow of a hand in sunlight. Measuring the shadow tells us about the size of the hand.
With the preliminary campaign in March of 2021, our focus was on trying to get a really good measurement of preliminary. And we indeed found the object we were looking for, and I was quickly building up an image and a profile of the object. And then there was two measurements from other team members that I plotted up that just made everything go crazy. And very quickly we realized this wasn't part of Pullemele, it was something that was orbiting Pullemele. We were running out of opportunities to find it again, and in February I realized, okay, we've got an event that's close. And so then I just sat down and said, where could it be? And that sets the region that I needed to cover around Pullemele and say, okay, how many telescopes does it take to do that? And the answer came back to be, well, I need 100 telescopes to make sure that I don't miss Sean.
This was a big operation. 4 nights before the occultation, almost 200 team members and volunteers assembled in Meade, Colorado. Many had never used this equipment before, and it was cold on that February evening. Cold enough to cause issues with telescope electronics and more.
This particular one, I understand, is the largest one we've ever done. And I will say it is very different in that respect. You know, the last one I was on was 12 people driving thousands of miles across Australia, which has a very different feel than 200 people and 100 telescopes, where you have logistical issues like how do you even set up 100 telescopes in one spot?
After a second night of practice, warming up, and debriefing, we all loaded up our telescopes and headed into the windy plains near Salina, Kansas, the closest location that promised to have clear skies. The evening prior to the occultation, team members set up for one final night of practice.
We are looking for an asteroid to pass in front of a little tiny star, and we're actually looking for a little satellite or moon around the Trojan asteroid that we're looking at. And so we're hoping to see this little tiny asteroid and a little tiny moon pass in front of a star and see it dim.
On event day, 94 telescope teams scouted our sites in Kansas, which were evenly spaced every 2 kilometers from Salina down to Wichita, 200 kilometers to the south. At sunset, we all drove out to set up our telescopes at our designated locations. Simultaneously, an additional 14 telescope teams were setting up gear in Spain to join in the campaign. Occultation volunteers Chelsea Farrell and Zaina Tarafter were assigned to one of the telescope tracks. They drove out to their telescope site and began to set up their equipment. Despite working perfectly during the practice sessions, Chelsea and Zaina's telescope would not come into focus.
That doesn't look good, but last time this happened, we had to reboot the whole computer. Oh, so exciting! Good job! Play top down.
They knew their telescope was pointed in the right direction, but if they couldn't fix the focus, they would miss the event.
Is that we might be getting interference off of secondary mirror. So yeah, look.
With less than a minute to spare, they found what was causing the issue and fixed it. But would they catch the occultation?
I don't know. I think I saw it. Oh my god. Oh my god. I don't want to say, because I feel like you always are going to think you see it. Oh my god, I'm really nervous. I mean, we won't know until they look at the data.
Over 100 telescope teams attempted to collect data. Had we captured the shadow of the asteroid Pullemele? Had any of our telescopes caught the much more elusive shadow of its small moon? We all gathered back in Salina, excited to warm up, to share stories from the night, and to analyze the data that had just been collected.
The moment of truth.
There it is.
It's not confirmed until Mark tells me. I need to. Isn't it?
Chelsea and Zaina were one of 10 teams that measured Ptolemy as its shadow passed over their telescope locations that night. Later that night, another team that recorded data 50 kilometers to the north confirmed that they also detected a small dip in star brightness, lasting only a fraction of a second. We had indeed located its moon. Using this critical information about the moon's orbit, Lucy mission planners will now be able to more accurately point the spacecraft's cameras to maximize the quality of science data that Lucy collects when it flies past Ptolemy and its moon later this decade.
Occultations are just fun. Even if you're not doing all the work behind it, just the fact that you could be sitting there and you're looking at this star, which, you know, normally you sit there and look at stars through the telescope, nothing really is happening. But then all of a sudden it winks out, comes back on, and now you've learned something about this object that blocked it out. It's almost like magic.
Excellent picture of John just there.
You want to say something more?
Yes, you can.
Hey, for anyone online that hasn't seen everything of this video clip, the link that we'll be providing you with will lead you to the whole clip anyway. Yeah? So stay posted. Thank you very much.
Thank you very much, Renato. Thank you for that excellent presentation. And the video and the questions and everything. So thank you very much indeed. I think we'll go back. Are we still sharing? No, we're not, are we? Okay, so in that case, I think once again, it was a great presentation, Renato, and we're very grateful indeed for it. Yeah, and we might move on to our next sections. I think we have some section directors' reports. Roy Axelson is going to do one on variable star photometry. Roy, yours is up here. Do you want to come and provide it? I can get it here. No, let's come off that. Are we still sharing that? Wrong one. That's what it was. I was looking at the wrong. We've got two laptops here and I was using the wrong one. There we go. Easily done. Mind you, if we have 100 telescopes, I think I'm looking to David here because I know he marshals lots of telescopes to get things. No, sorry, I got it here. But I know you marshal lots of telescopes for our education night. So let me know when we're up to 100, won't you, in the future? And I'll let you go with your variable star one. Roy, do you want to set up or do you want me to bring it up?
I can probably do it, but don't go too far.
Okay, all right.
Now, where do we share?
We need to go into Zoom to share.
Where are we?
Roy, easiest way to do it is this way.
I've lost it. There's someone there.
Yeah.
It's was this one down here? Is that it?
Yeah, that shows, but they can't see it
yet.
yet.
They can't see it. Okay.
Oops, no, we don't want to leave the meeting. Okay.
One in the middle. That's it.
Yep.
Let's look like it's
should be right. Disappearing.
Okay. A couple of years ago, I bought this telescope. Can I get rid of that at the top? This one, this band of great. A couple of years ago, I bought this telescope, which is a Celestron Next Star Evolution 8. That's an 8-inch diameter mirror. There are 5-inch, 6-inch, 8-inch, and 9.25-inch models. It's on an alt-az mount, and it's designed specifically for visual observation. And I take it along to the AAQ school nights. Now, most of my variable star work I do with quite small aperture lenses and telescopes, but here I have an 8-inch instrument, and I thought, is there some way that I can use this for variable star photometry? And of course, it's not much good taking photographs with an alt-az mount. So I decided that I'd buy a Celestron wedge, an equatorial wedge. It's a pretty massive device, and it weighs several kilograms, but even at my age, I can carry it with one hand after I've picked it up, and that's the name of the game. When the telescope is mounted on this wedge, it looks like this. So the wedge is from here around here to here. The telescope here is pointing to the west, and the camera's upright. But when in fact you point to the east to start observing for a run during the night, the telescope's, the camera's right upside down. So I have a tether to make sure that the camera doesn't fall out of the star diagonal. The reason for doing a star diagonal or using a star diagonal is that given that it's on basically an alt-az mount, there isn't enough room to have a straight through position for the camera. Otherwise it will collide with the base of the mount. It looks as if the star diagonal is going to hit the azimuth adjustment knobs here, but they're further away from the camera than the base of the mount. So this is a Celestron instrument, and Celestron is a bit unusual. To align this, you need the Celestron plane wave instruments app, the CPWI app. Now, the Celestron telescopes don't allow you to synchronize the mount to any position in the sky. You actually have to align on bright stars. And the idea is to align on 3 or more. I don't do that. I simply turn it on, and the telescope won't move until you tell it to go to one of these alignment stars. Once you've done that, I then switch to the astrophotography tool, take an image, use astrometry to tell me exactly where the image is, and then synchronize on that position. So the important thing is to take an image of a region of the sky near where you want to take your photometry. Once I've done that, I've got auto guiding so that I can follow the star throughout the night. And this is the sort of result that I can get. This is an 11th magnitude star, and that's the variable star through over several hours. The check star is a horizontal line, no variation in the magnitude at all. That's one of the best light curves I've ever got, and I can't achieve that very easily at all with smaller aperture equipment or smaller diameter lenses or mirrors. Another star, these are eclipsing binaries, a 12th magnitude star down to about 12.5. And again, it's a pretty good light curve. The objective of getting the light curve is to determine the precise point of the mid-eclipse so that any changes in the period of the star can be determined. So that's it. It was a success. Once the computer is talking to the telescope and all the other equipment and all the software works properly, this is the sort of thing that you can get. I should have explained that the reason for using an equatorial wedge is that you don't need to do a meridian flip, so that I can set the thing going. It runs all night. I can go to bed, wake up whenever I do in the morning and turn it off. So you don't have to worry about a meridian flip, and therefore there's no interruption to the light curve of the star. So it's very convenient once you've got it working. That's it. Thank you.
Thank you, Roy. Any questions to Roy? Yes, you might pass the microphone back now.
Thank you. That was very interesting, Roy. Is the only reason for using the wedge to avoid that thing that you referred to as the meridian flip, because the field rotation as the object moved, if you tracked it with an alt-azimuth mount, it would be irrelevant for a star because there are no visual features on it to actually take account of Is that right? Am I thinking right?
So the wedge converts an alt-azimuth mount to an equatorial style drive, so that you don't have to worry about field rotation. I bought the wedge because I didn't want to buy yet another mount. The wedge only cost a few $100s. So that was the one thing. I could convert with just a few $100s to an equatorial drive. The second thing, of course, is that there's no meridian flip because it's not a classical German equatorial mount. The drive just keeps going all night without the need for any flipping.
Thank you.
Questions online? Ready?
Okay. So
David, I think, oh, sorry.
I've got a question. What exposure times you need to do for these observations?
sorry, Renato, I couldn't quite hear that.
What the exposure times for the observations?
1 minute or 2 minutes, just depending. I think it was 2 minutes for those two stars.
Thank you
It was
very much.
11th and 12th magnitude.
Okay, thank you very much. In that case, David's got the second director's report as well.
I'll let you get out of that. Thanks.
Joe, can you see those slides?
Yes.
Good. For those of you who were listening to Renato's talk, he's not the only one who's been to Houston Space Center, as is evidenced by my T-shirt, but I won't bore you with that. This is the education section. I want to talk about the team and what we've done so far and what we have ahead of us. First, I want to really thank the team who do the education outreach. This is going to schools, community groups, what do they call it, probus clubs, things like that. We've had a great group who have, over the last couple of years, really put in an effort. I particularly like to thank Roy and Tim, who have both done an outstanding job and have been regulars at most nights. And Roberto and Denis and Renato have turned it up. Terry and John have even on occasion done it, but Terry's a long way north, up Scarborough, and John's on the Gold Coast. So when they turn up, it's a real event. But this year so far, we've had 1 out of 3 that have worked. We had the first one earlier this year was for a community group, and we cancelled it at lunchtime at 1 o'clock in the afternoon because the weather was so appalling. It was leaden skies, just awful. And at 6 o'clock, everything cleared, but we'd already cancelled. So that's the worst part of this job. I'll talk about the Queensland education thing in a minute. And we had one group that was a couple of, a week or 2 ago, and we've deferred them for later in the year. The Queensland education event was the second time we've been invited to do this, where they run a program for teachers who are wanting to become principals or deputy principals. And it's a program that they run remotely, and then they come in for a week to do a residential thing. And they call it, the theme of the event is Look Up, Look Out, which is really about what they're trying to get principals to look more into the future. But as a result, they've taken the astronomy theme. And so last year they had Sarah Sweet from UQ doing an event here, or giving a presentation. That was a night of one of the worst thunderstorms Brisbane had had in years. So I was doing a show and tell with the telescope, you know, standing, look at this, here's one I prepared earlier while it was pouring outside. This year was at QUT, and Dr. Michael Cali, who's a member of the AAQ, was there. And I think I understand why we've got so many new members, because I was talking to Michael during the event, and he has been strongly advocating amongst his PhD students that they should all join. So I suspect some of those people are the people we've got new members, so that's fantastic. Michael gave a great presentation about Indigenous astronomy and how his experiences related to teaching and that sort of thing. So that was a really good presentation. It was really interesting. He took some of them up to probably the most light polluted observatory in Australia. This is on the top of a building at QUT, right in the centre of town. You can see just from the light reflected from the dome, like you can drive along the expressway and you can see the dome on the top of the building, that brightly lit. Somehow they still do astronomy. I've got to tell you, it wasn't just up there. So this is the main section of QUT's campus at Gardens Point. And their event was held in this tiny little cafe sort of historic building over on the right-hand side where the yellow arrow is pointing. And that was where I had to set up. And you can see there, these were the stairs at the bottom, a very brightly lit street light there. There was one just about 3 meters away from me lighting this area and lights there. It was possibly the worst place I could have possibly set up the telescope. However, one of the nice things about the Unistellar is we were still able to get a fabulous view of Eta Carina, which was the only object we could see for all the trees, because it wasn't just light that was a problem. You can see that this is in this sort of well amongst trees, but the telescope is really fabulous. So if people have not seen that scope in action, I strongly encourage you to come along to one of the post-meeting nights, although I didn't bring it with me today. I'd love to show you just what it can do, even here in the light polluted areas of St. Lucia. So what have we got between now and the end of the year? We did have one in June for BBC. That's been deferred to term 3 with the school's request. Bray Park is a repeat customer who have booked us in for August. August is a big month. We got another one for All Saints. Both of those are in the north of Brisbane, so they're a bit of a drive. And I've got to be honest, I have no idea where Mabel Park is. I haven't looked at it yet, but we've got them, and they're a new group who have come to us. And we've got BBC, which is our local one, and King's College to reconfirm for a date. So we've got a busy year ahead of us, and then there's the one in Toowoomba who I've got to reach out to. So it's quite busy. So I need more volunteers. So this is the plea tonight. I'm asking for people who have an interest in doing this. You don't have to attend every session. You don't have to own a telescope. I've got the AAQ's 8-inch go-to Dob at my place, as well as the Unistellar. We can provide the telescopes, and you don't need to be an expert, as evidenced by the fact that I run the section. That's, thank God for go-to telescopes, is all I can say. For schools, we do need you to have a blue card. I mean, some of the schools don't care, but council decided a couple of years ago that we'd do the blue card thing. But it's really straightforward to get, especially if you've got a fairly recent photo on your license, because they have to have the biometric photo. But it's really straightforward, and we've got it down to a fine art. You don't have to fill out any forms. It's just an online process. I'd also remind people, if they are renting any of the AAQ scopes, you get a month's free rental if you bring it to any of our field nights. And also you get access to the Unistellar, because I'm looking to train up people on how to use the Unistellar, so it just doesn't have to be me all the time. So if you have any interest in joining the education team, even if it's only for one event a year, or an event that's close to you. Terry, for instance, doesn't go to every event because he's so far north. But if you've got any interest, please let me know. And that's it.
Thanks very much indeed, David. Are there any other questions to David, either online or here? or volunteers. Feel free to volunteer to him, won't you? He's very keen to hear from you. Don't hold back. Don't be shy. Okay, I don't see any other questions at the moment. Thank you. Are there any other section directors who have reports? I haven't had anything from them. I'm just checking. Not online. No. In that case, I think, Joe, you have an item of astronomical interest to share with us, don't you?
Yes, that's right. I think you need to stop sharing so that I can.
Where is it? Somewhere?
Actually,
I think we have stopped sharing, haven't we?
I can override from here.
Yeah, we have. Yeah.
Seeing the Zoom viewer.
Oh, it's up there.
Yes.
Yeah, we have. Yeah. Over to you, Joe.
Okay, so you should be seeing the an Aurora still.
Yes.
Yes. Okay. Terrific. So I spent the month of May in Tasmania, traveling around, but also doing Aurora chasing. Friends of mine who are members of the AAQ, Greg Bond, Tony and Wendy Dutton, went down for 3 weeks around the new moon at the end of March, and they got pretty much all cloud, and on the few clear nights, no aurora. So I wasn't holding out any high hopes. I arrived on April 30th, but my first night of observing was May the 1st, and I got auroras the first 3 nights I was there, and clear skies. So this is just near St Helens, out on the peninsula, and this one, then I actually spent about 15 of the 25 nights I was in Tasmania camping at beachside locations, which sounds terrible, but the East Australian current brings warm water down from Queensland along the New South Wales Victorian coasts and past the East Tasmanian coast. So it was actually it was cool, but it certainly wasn't cold. There were a couple of cold nights, but I brought gear ready for really cold weather and barely used it. This was the 3rd night, and this was the night of the federal election. So I was actually lying on this beach here on the Bay of Fires, listening to the election results and photographing this beautiful aurora. And then I didn't get any more aurora, but I did get some beautiful airglow events. So this was when the moon was gibbous waxing, and so there was a big gibbous moon in the sky. So I'd set my alarm and wake up at 2 or 3 a.m. after the moon set, and didn't get any aurora, but I got these beautiful airglow displays. That's a sunrise and, sunset, and that's another airglow. So the different colors are different energies of the excitation and different gas molecules. So I've got a video of my 5 nights, but I'll just keep going forward. So I got back here to central West New South Wales, and last Sunday night there was another quite big auroral storm, what's called a G3 or G4 event, and I captured quite a few. I actually captured 1,000 frames over 6 hours that I've put into the video. You'll be pleased to know I'm not going to talk through all 1,000. But the brightest part of the storm only lasted for about 45 minutes to an hour. And so I'll now hop over to the videos. Start with Tasmania. Now, on these nights, I had problems, as you'll see, with fogging. Both of these nights, 2nd and 3rd of May. And although I had a heater strap, I forgot to bring my portable power supply. And a friend of mine who's a very good astrophotographer loaned me one after that. This was a much less active display than the first one. Now let me go to this is June the 1st. I started this right at sunset. The auroral flare hit, or the solar flare hit at 4 p.m. in the afternoon, and so we knew that there was likely to be activity right from twilight. So around 6, this video started at 6:15 p.m. and I captured frames right through till I think about 11:30 that night. So it was 1,000 odd frames captured, and here we go. This is where it became visual at this point, and this was widely observed all across New South Wales.
Joe,
Victoria.
we can't see that video.
The bright yellow here is a limestone mine that's about 50 kilometers away. And when there's low cloud, it reflects off the cloud.
Joe, we still can't see the video.
Thanks very much.
Thanks very much, Joe, and thanks for your thanks for that very interesting those observations. Any questions or comments to Joe on his observations?
Yes,
David,
Joe, given your success compared to the Duttons, were you quickly unfriended on Facebook?
I'm actually not friends with the Duttons on Facebook, and Greg Bond doesn't use Facebook. So I very quickly sent copies of the photos to them.
I'm sure they were extremely pleased to get them. I hope they congratulated you, Joe. Okay, if there are no other questions to Joe, thank you very much, Joe. Is there any other items of observations or items of astronomical interest anybody wants to table, either in the room or online?
Yes.
You do,
Hey.
John. Over you go.
Can you hear me?
Yes, we can hear you.
Okay.
And
Just
see you.
further, sorry, I'm going on and on about this sonic boom thingo from in April. There's been a lot of interest down here, and the thing that just happened recently, a friend from the field naturalists here happened to have a security camera on at a friend's place. It wasn't her security camera, it was a friend's phone, and they caught it. The thing was on for the whole time, and she edited 2 clips from the video showing the brightening and then the actual meteor going through the sky in the corner of the field of view, and then she sent me the clip that contained the sonic boom. Have a guess how long the gap was between the visual and the boom.
12 seconds. I've got from here, John.
4 minutes.
Oh.
4 minutes. So, it was a fair way away. The visual thing you saw in the sky was obviously, I don't know, hundreds of kilometres away. What is it? 3 kilometres per second, the speed of sound. So if you work it out from that, 4 minutes is, what's that? 4, 6, 240.
No, it's 3 seconds per kilometre. So 240 seconds.
3 seconds per kilometre, sorry, yeah.
3 is about
yeah.
80 kilometres.
Divide it by, yeah, that's right. It's less than 100. Yeah, that's right. So that was, in fact, Peter Anson's back of the envelope track wasn't too far off it. Yeah. So that's just, sorry, that's about that sonic boom thing. April the 21st it was. Thanks,
John.
Thanks.
Any other items of observations or items of astronomical interest to be tabled? Either here or online?
Oh, just a quick note. I was actually interviewed on ABC Sydney morning breakfast radio about the Aurora on Monday morning. So that goes out to, I think they have not far short of 1 million listeners there. And then ABC Online picked that up and asked me for a photo. And so there was a story that went out online with one of my photos.
It was on ABC News too. It was on ABC News, national. Yeah.
Congratulations.
Thank you.
Okay, I think if there's no further items to be tabled, we're on to general business. Anyone want to raise any general business? I'm looking in the room. No? Yes. Graham, you might need a microphone, Graham, so everybody can hear you.
We're here in the auditorium. Just a reminder, the library's open after the meeting closes tonight. And we have sticky biscuits and coffee and tea out there for everybody to enjoy and socialise after the meeting.
Thank you.
Thank you.
I'm sorry you'll miss out on those online, but there we are. You can imagine them, and Graham can describe them to you at some point.
I won't even mention the chocolate brownies that are sitting out there with my name on them.
Have one for me.
Could I just remind the people online that we hang around after the meeting ends and have a chat. And I know a lot of people rush off to have dinner or whatever, but if you want to stay and have a bit of a chat, please feel free.
Thank you. And I think with that, we've come to the end of our meeting today. So thank you to everyone who contributed, to Renato for the main item, and to all the people who presented today, Joe, David, Roy, and so on. So thank you indeed. And I think it's time for us to conclude here in the meeting room and allow you to continue online, Joe. And we'll go and have some tea or coffee and some biscuits and think of you. Thank you. All right. Have a good evening, everyone. See you next month. Next month, by the way, is an interesting one with John Colton, Associate Professor from the Andy Thomas Centre for Space Resources. I think you're going to enjoy next month's presentation.
Thanks, Nick.
Goodbye. Good evening, everyone. Take care.
Bye.